Hello everyone, welcome to Coders Camp. We are at 18th day of November LeetCode challenge and the problem we are going to cover in this video is Hamming distance. So the input given here is a two integer value x and y and we have to represent those two integers in form of binary and we have to return the number of positions at which the corresponding bits are different. So x and y return Hamming distance between them. So let's understand this with an example. So consider two numbers 7 and 5 and we have to represent them in binary first. So representing 7 as 01111 and 5 as 0101. So we have to return the number of positions where the bits are different. So let's start comparing the bits. If you see at first position 0 and 0 are equal. Next 1 and 1 are equal. So here 1 and 0 are different. So we have one position added to our output and next value is 1 and 1. So except this position, all of the positions are having same value. So 1 is going to be our output. So how are we going to approach this programmatically? So there are pretty easier ways in Java and C++. There are predefined methods that calculate the number of bits. And for example, in Java, you can use bit count to count the number of bits in the integers and etc. But the purpose of this program is to do that logically instead of using predefined functions. So how are we going to do that? So we need to know a bit of bit manipulation functions to solve this. So first thing is we have to have the number of positions where the bits are different. So we have a lot of operations in bitwise. So which operation will actually give you 1 when the positions are different and 0 when the positions are same. So which is nothing but XOR. So XOR will actually give you 1 in the output when both the numbers are equal. Sorry, when both the numbers are different. That is 0 XOR 1 is equal to 1, 1 XOR 0 is equal to 1. Otherwise, if the numbers are same, then they are going to give 0. So this is the function we are going to use here to find wherever the positions are having different numbers. So let's do x XOR y, which is nothing but 7 XOR 5. So which is going to give you 0, 0, 1, 0. So we have got a final product which represent 1 wherever the numbers are different. So now we came to a point at the program that we have to count number of ones in the given binary representation of the number and we are done. So how many number of ones are there will be our output. So here 1 is going to be our output. So how are we going to count that? So again, we have a lot of options to calculate the number of ones in the given binary number by converting that to a string and comparing the bits, or again using the bit count method and etc. But here again we're going to use the bit manipulation operations to find the number of ones in the given binary representation. So how are we going to do that? So how are we going to calculate the number of ones in the given binary representation? So we're going to get the help of AND operation to do that. So purpose of AND is if we do AND 1 with any bit, if the bit is 1, it is going to give 1. That is 1 and 1 is going to be 1. Otherwise, if the bit is 0 or whatever it is going to be give you 0. So this is going to give you 1 only if there is a 1. So we are going to perform AND operation which each of the bit, and whenever there is a 1, we are going to increment the counter of our result. So let's have result is equal to 0 and start doing AND operation with each bit. So the last bit is 0. So 0 and 1 is going to be 0. So result still stays the same. So the next integer is 1. So 1 and 1 is going to give you 1. So we are going to update our result to 1. And then comes a 0. So it is going to give you 0. So the result is going to be stay the same. And again 0. No change in the result. And finally result is going to be 1. So it is pretty simple by doing an AND operation to find whether it is a 1 or 0 and adding or incrementing the count of a result based on the ones we encounter in the x or y. So again, how do we do specifically to each bit AND operation? So which is pretty simple again. We have used a lot of times right shift operator to shift one bit at a time. So what will this do actually is, if suppose the number is 1010, one time if you do left shift of 1, it will shift the last bit over and move all the bits towards the end, which is nothing but it is going to push this 101 towards the end. Again, if you do, then it is going to push this 1 and 0010. And again, when you do, it is going to push this 0 and number is going to be 0001. And again, if you do, it is going to become all zeros. So its purpose is to shift the last bit and push all other bits towards right. So we are going to imply the same to this number. So every time it is going to have the last bit and we perform an AND operation and then shift it over. So now we are going to perform 00010 right shift 1. So what this will do, this will shift one operator next to it. Before that we'll perform an AND with 1, so the result is going to be 0. So after we shift it, the number is going to become 0001. So now it's time to perform AND operation 1. So now 1 and 1 will give you 1. We are going to add that to our result and then do again a right shift to this number. So once you do this, this is going to become all 0. And yes, once it becomes all 0, we know we can't further shift it. It is going to be all 0 all the time. So that's it. We are going to return our result. So we are going to perform this right shift operation until the number becomes 0. So hope you're understanding this concept. This is pretty simple if you already know about XOR and right shift and etc. Otherwise, it is always good to learn this simple logic so that we can approach many bitwise operations in a very simpler way. So let's go to the code now. So as I said, first we have to perform an XOR operation to the given numbers. So once we perform this, we are going to iterate this bit until it becomes 0. We are going to perform a AND operation with 1, and if it is a 1, then we are going to add to our result. So let us declare result as well, which is what we are going to return finally. So now every time we perform an AND operation with XOR, we are going to add its result. Anyway, 1, it is going to give you 1 or 0. So if you add 0, that doesn't matter. So finally, every time we perform the addition and update the value to our result, we are going to do a right shift to our XOR. Yes, this is it. Let's give it a try. So let's submit. Yes, the solution has been accepted and it runs in 0 milliseconds. So thanks for watching the video. Hope you like this video. If you like this video, hit like, subscribe and let me know in comments. Thank you.